So my name is Andrei Lazar, and I'm the founder of the Reverse NSS Biotechnology company. In the following moments, I will present you the MetaboAge database, which is a repository of known aging-related changes in the human metabolome. The MetaboAge project was realized by a synergic work between the System Biology of Aging Group, Reverse NSS Biotechnologies, and Kronos Biosystems. Because metabolomics provides an instant snapshot into the metabolic state of tissues and organs at different ages, it is starting to become an extremely useful tool in understanding the aging process. And as the research on aging is a rapidly emerging field, new tools for the collection and integration of aging and age-related diseases are being frequently developed. However, there were no tools specialized in aging metabolomics, and because of this, we developed the MetaboAge, human aging-related metabolome database. The MetaboAge aims to provide intuitive bioinformatics tools for the visualization, interpretation, and analysis of pathway knowledge, and to offer to the scientific and medical community a general reference source that integrates metabolic data. The scientific articles were continuously screened from PubMed and were automatically selected by a custom-made Python, Postgre, or PostgreSQL scripts using specific keywords that are related to aging and metabolomics. After this step, the final manual literature selection is taking place. Basically, the curation process is done by a strict SOP, a standard operated procedure. The SOP contains detailed written instruction regarding the literature and selection and the database curation. In order to collect the metabolites and their variation with age, several criteria need to be met. For example, subjects need to be in a healthy state. Study must be in vivo, and the variation needs to be significant with age. If these criteria are not met, the article is rejected and is not further curated. From the accepted articles, the extracted information are metabolite variation with age, metabolite variation with age depending on sex, and the validation methods of the metabolite. It doesn't change my my slide right now. Can you hear me?
Yes, we can hear you. We can see when you're.
It freezes my slide right now.
Maybe you have to refresh it.
Okay.
Okay. Sorry.
Okay. The location ontology was created with the Protege software, and as you can see, each metabolite class can have one or more superclasses and comprise one or more small molecules metabolites and or other one or more subclasses. User interface. User can browse the database by a list of metabolites, a list of pathways, or by browsing the location ontology. Each individual metabolite page contains metabolite-centric information, such as chemical information, external sources, involvement of the KEGG pathways. The pathway info panel displays information about the pathways in which the metabolite is involved, as well the pathways map that are imported from a KEGG database. Also, we provide information about the products and the substrate of the metabolite in a certain pathway. And this individual page also have information about the ontology location of the metabolite, where you can browse the classes in which the metabolite is found from a tree. And by doing this, you can see all the metabolites that are in that specific class. Also, there is an option to browse the entire ontology by clicking the upper left button. By browsing the pathways, the user can choose to visualize all the associated pathways with a metabolite, or to visualize all the metabolites that are associated with a certain pathway by clicking one of these two buttons. Results. Each metabolite class presents chemical informations, reported variations between age groups and metabolic pathways. And by an ontology browser, it is allowed to users to surf the data based on metabolite location in the human body. Below, you can see a table with the metabolite statistics and metabolite variation statistic of the MetaboAge database until this moment. The most studied metabolites based on MetaboAge are creatine, lactate, and N-acetyl aspartate. Here you can see the number of the variations and the number of scientific articles for each metabolite from where the variations were collected. In conclusion, MetaboAge is a repository of metabolic variation in healthy aging, providing quality data. Is manually curated through a well-defined procedure, an SOP. We have a very well done SOP. It has integrated chemical annotation for molecular metabolic entities, categorizes data based on in-house constructed location-based ontology, and provides associations with human metabolic pathways. Acknowledgements. I would like to express my special thanks of gratitude to Dr. Robi Tăcutu, who made this project possible. I also want to express my gratitude to the rest of the authors for their efforts in this project and the opportunity to work in such a wonderful team. And a big thank you for having your attention.
Thank you, Andrei. Very nice presentation. I think we have a few 1 or 2 minutes if anybody has questions about this. Please unmute yourselves if you want to ask a question, or write in the chat if there is a problem with unmuting.
Okay. Yeah, I have a question. Can you hear me?
Yes, I can hear you, Cyril.
Yeah. No, so let me try to formulate. I'm not familiar with metabolites, so maybe the first question is, biologically speaking, do we know well kind of all the list of metabolites, or are like there are a lot of compounds we have no idea about? And based on that, the real question is, when you say you have only kept the ones that change with age, have you also kept a note of the ones that do not change with age? Because you could have 3 categories: the ones that do not change, the ones that change, and the one we don't know, right? So I don't know if this is important.
Yes, I think there are lots of metabolites that are not changing with age, and it's a tremendous work to do that. And I don't think for our database it will be very relevant. So okay. Because of this, we only capture the metabolites that show variation in a healthy aging states, because there is also the disease state, which is more complex.
Yeah, okay. So you said you had like hundreds of metabolites in the database, right? Do you have an order of magnitude of the number of metabolites in general? Like, do you have thousand or tens of thousands? Or?
10 of thousands are.
Okay. Okay.
There is the human metabolome database, which you can see the majority of the metabolites,
Yeah.
and but there are not specific to age.
Okay.
So,
thank you.
Okay.
This database is more specific to age.
Vadim, you also wanted to ask a question?
Only a very short comment. First of all, nice job.
Thank
It
you.
is really very timely and very important and very useful database. That's all.
Thank you so much. I appreciate. We appreciate.
Thank you, Vadim. If there are no other questions, then we have to move to the next speaker, which is Gabriela Bunu.